All right, so you've built all these amazing individual pieces for your Java application, and they work perfectly on their own. But what happens when you plug them all together? That's the real moment of truth, right? And it's exactly where integration testing comes in. It's the absolutely crucial step that transforms a collection of parts into a real, fully functioning system. So let's break it down.
Here's how we're going to tackle this. First, we'll get into the what. Then, we'll talk strategy and workflow. After that, I've got some pro tips to make your tests super clean, and we'll finish up with the must-have tools for your toolkit. By the end of this, you're going to have a solid roadmap for integration testing.
So, first things first, what exactly is integration testing? Let's talk about getting all those pieces to play nicely together.
Think about it like you're building a car, You can have a perfectly engineered engine, a flawless transmission, but integration testing is what confirms that when you actually connect them, the car drives. See, it's not about the individual parts anymore. It's all about the assembled whole.
Now, a super common question is, how is this any different from unit testing? Well, it really just comes down to focus and scope. Unit tests are laser-focused, they're narrow, they're fast, and they check one tiny piece of code in total isolation. Integration tests, on the other hand, are broader and, a bit slower because they're checking how multiple pieces actually interact. It's like this. One tests the brick, the other tests the wall.
Okay, so you get what it is. Now, let's talk strategy. How do you really want to put this whole puzzle together?
And the choice, fundamentally, boils down to this. Are you going to connect everything at once and just hope for the best? Or do you take a more methodical, step-by-step approach?
These two philosophies are what we call Big Bang and incremental. With Big Bang, you literally just throw everything together and test the whole system at once. It's quick to set up, but man, if something breaks, good luck finding where the problem is. Incremental is way more deliberate. You add and test pieces one by one. Sure, it takes more setup, but it makes it infinitely easier to find failures early on.
And even within that incremental approach, you got a few flavors. You can start from the bottom, the foundational stuff, and build your way up. That's called bottom-up. Or you can start from the top, like the user interface, and work your way down using placeholders or stubs for the parts that aren't built yet. That's top-down. And of course, you can do both at the same time in a sandwich approach and meet in the middle.
Okay, you've picked your strategy. Now what? Let's look at the actual testing workflow. This is your blueprint for success.
I love this quote from Brian Tracy because it just perfectly nails this next point. In integration testing, planning isn't just important, it is everything. A little bit of foresight here is going to save you from massive headaches down the road.
And here's that plan, laid out in 4 clear steps. First, you plan and design your tests based on what the system is actually supposed to do. Step 2, you set up a test environment that mirrors the real world as closely as you possibly can. Third, you execute the tests and you carefully log anything that goes wrong. And finally, you retest the fixes and you report on what you found. It's simple, it's structured, and it works.
All right, you've got the fundamentals down. Now let's talk about what separates pretty good integration testing from truly great integration testing. These are the pro tips that are really going to level up your quality.
This analogy is just perfect. Your test environment really is everything. I mean, if it's messy or inconsistent, or it looks nothing like your production environment, your test results are basically useless. You have to cultivate this clean, isolated space for your tests to really thrive. So how do we actually do that? Well, first, create that clean, isolated environment. Tools like Docker are amazing for this. Next, use things like dependency injection and mocking frameworks to easily swap out real components for test versions. This helps you zero in on what you're actually testing. You could even adopt test-driven development, where you write the test before you write the code. And finally, just be smart about it. Always prioritize the riskiest parts of your system first.
Now, of course, you're not doing all of this by hand. No way. There is a whole ecosystem of tools out there designed to make your life so much easier. So let's do a quick tour of the essentials for your Java testing toolkit.
If you're working in the Spring ecosystem, the Spring Test module is a no-brainer. It's built to manage your application's context and transactions, letting you test all the layers of your application just seamlessly, from the web controllers right down to the database.
And then you have JUnit. I mean, it's the bedrock of all Java testing. While a lot of people think of it for unit tests, its flexibility and all the integrations it has make it an absolute go-to for setting up and running your integrations tests too. Okay, now this tool, Test Containers, is really cool.
Remember that whole clean environment problem we just talked about? Well, Test Containers basically solves it. It lets you spin up real services, like a database or a message broker, inside a temporary Docker container just for your tests. And when the test is done, poof, it's gone. This is an absolute game changer for reliable, isolated testing. And finally, there's WireMock. So what if your application relies on some third-party API? You don't want your test to fail just because their service happens to be down. WireMock lets you create a fake version of that API, which gives you total control and makes your tests 100% reliable.
So after all of that, it really just comes back to one simple question. Your code might be brilliant in isolation, but does it actually play well with others?
In answering that question, well, that's the entire point. Integration testing isn't just some box you have to check off. It's the process that turns a collection of independent modules into a single, cohesive, reliable piece of software that actually works for your users.
And that leaves us with one final thought to chew on. In today's world of microservices and complex APIs, our systems are only getting more and more interconnected. So the real challenge moving forward is this. How do you keep your test environment from becoming even more complex than the code you're trying to test? It's something to think about. Thanks so much for joining me.